Good morning, class. I've tried this several times, so I guess I'll try it again. I am having technical difficulties, and this is what has been going on the whole time, and that's why I have been not able to do the videos because my phone. I have access to another phone, and it's still messed up. So let's just do the best that we can. I know you're going to see this in here a couple times, but at least you'll be able to ask questions. We're on section 11.2, which is combinations. We are going to be distinguishing between combinations and permutations. Find the number of combinations of n objects taken r at a time, and use the combination rule in conjunction with the fundamental counting principle. First things first, a combination is a selection of objects without regard to order. So that means if we have a classroom with about 30 people in it, and I ask the class to get in sets of 3, it doesn't really matter what 3 they are, as long as they are in sets of 3, which will be different combinations. There's no distinct characteristics to the request. Alright, so one again. It says given 4 roommates or 4 housemates, Ruth, Elaine, Alma, Jasmine. List the permutations and combinations when you are selecting 2 of them. Alright, so on my whiteboard, I have listed Ruth, R, E, Elaine, A, Alma, and J for Jasmine at the top. I have put them together, going Ruth, Elaine, Ruth, Alma, Ruth, Jasmine, Elaine, Ruth, Elaine, Alma, Elaine, Jasmine, Alma, Ruth, Alma, Elaine, Alma, Jasmine, and Jasmine, Ruth, Jasmine, Elaine, Jasmine, and Alma. So looking at all 12 of these will be considered 12 permutations. The reason why they're permutations is because there's a distinct order. So let's say we're talking about them, like they said, they're housemates. So we're selecting 2 of them. We have selection 1 and selection 2. So anyone that's in this first row or first column is going to be selection 1, and anyone in the second row second column are going to be considered selection 2. So as we notice, all 12 of those are different because we have 12 different combinations, or 12 different, you can say 12 different situations where they are set up differently, like Ruth, Alma, Alma, Ruth, Jasmine, Elaine, Elaine, Jasmine. But they are 12 different ones because position 1 and position 2 have different people in them in all 12. Now, from before, I have lines under them to show you the combinations. So if we go to Ruth, Elaine, or Elaine and Ruth, those are 2 combinations of the same people, so that can be considered as 1. If we did Elaine, Alma, and Alma, Elaine, that there too is 2 permutations, but are a combination of both. So in reality, we have 12 permutations and 6 combinations. There, right there in front of you, are the 12, and they mark out 1 so they won't be doubled, and they call them double because they have the same 2 people. And with that being said, we have 6 combinations. 12 permutations, 6 combinations. The difference between permutations and combinations, it absolutely matters. Absolutely matters what position they are in or order they are in with permutations. But combinations, order does not matter. Okay, for example 2, it says decide if each selection is a permutation or a combination. So for the first one, it says from a class of 25 students, a group of 5 is chosen to give a presentation. B says a starting pitcher and catcher are picked from a 12-person intramural softball team. Okay, in this situation, let's go to A. When A says from a class of 25 students, a group of 5 is chosen to give a presentation. The key factors there is that 5 people are chosen out of 25 students. There is no regard to order. There is no regard to anything specific about those students that are chosen. So that means that will be a combination. For B, it says a starting pitcher and catcher are picked from a 12-person intramural softball team. Now, as we know with sports, they have different positions. And because they told you a pitcher and a catcher are to be picked, then that means there's a distinct order or something specific that has to be known. And with that being said, B is a permutation because order does matter. Now, if you go further to your PowerPoint, the explanation that they give you is pretty much the same. It says that A is a combination because there are no distinct roles for the 5 group members, so the order is not important. And for B, there is a permutation. This is a permutation, because each selected person has a distinct position, so order does matter. All right, here they have now given us the combination rule. And the combination rule makes solving for combinations a lot easier because you can just plug numbers in and find it swiftly versus trying to figure out how many of something you have in a combination. So the number of combinations of n objects taken R at a time is denoted as NCR and is given by the formula NCR is equal to n factorial, which we talked about factorials in 11.1, over n minus R factorial. Please make sure that in this particular type of equation or formula that you are be sure to use your order of operations. And I am saying that because you notice in the denominator, you have to execute parentheses first before you go further. 2 other things that I need to make sure that you are familiar with in this problem is going to be N and it's going to be R. Remember that N is the total number of what you are using or what category you are using. The total entire number. R is going to be the specific number of spaces you have or a specific number that you are trying to find in your equations or your problems that you are looking for. So here it says how many combinations of 4 objects are there taken 2 at a time. So let me take my little towel and get the board right. Sorry, I don't have an eraser like I'm at school. All right, so we know we had NCR is equal to n factorial over n minus R factorial R. Now, I'm going to be honest with you. There are going to be some points where I may have to go to paper or may have to erase and go back, but that's only because I don't have a big board. I just have something that I can work with to show you what's going on. So here it says how many combinations of 4 objects are there taken 2 at a time. So they told us totally we have 4 objects and we're looking at 2 at a time. So we can come here and plug in and we have 4 for N, C is combination, and R is 2. So we're going to plug in 4 factorial over 4 minus 2 factorial, 2 factorial. So that's us simply just plugging in. That's just simply us plugging in 4C2 into the N and R's. So we're going to come here after substitution. We are going to actually simplify. So we have 4 factorial, which was in the numerator. And with our denominator was simplifying, that is going to be 4 minus 2, which is going to be 2 factorial over 2, next to 2 factorial. So now, with the rules that we know from before, we can do our countdown to our largest number in the denominator when breaking them down. So we can do 4 times 3 times 2 factorial over 2 factorial, where those two cancel to be 1 and 1. And we're going to break down the other 2 factorial, which is 2 times 1. So here I am going to simplify. 2 can go into 2 one time, and 2 can go into 4 2 times. So now at this point, I have all 1s at the bottom, and I have 2 times 3 at the top, which is 6. So that means that our combination will consist of, they did the same thing we just did on the board. It will consist of 6. I'm going to put this up here for a second so you can see what we did as well. So 4C2 breaks down to be a combination of 6. Okay, so this is a little bit bigger problem, or longer. It says, while studying abroad one semester, Tran is required to visit 10 different cities. He plans to visit 3 of the 10 over a long weekend. How many different ways can he choose the 3 to visit, and assume that distance is not a factor? So first thing we need to make sure we notice is that he can go to 3 cities. So 3 is going to be our R, and he has a vast choice of 10. So 10 different cities. So we'll come back here for our first one, and we have 10C3. Now let me get all the other old stuff from the other problem out the way. I'm sorry. Okay, sorry about that. So we have 10C3. Let's plug in. We're going to have 10 factorial over 10 minus 3 factorial, 3 factorial. So that's doing nothing but replacement. 10 different cities, and he has 3 he can go to over a weekend. So now, after replacement or substitution, however you want to consider it, we come down here and we simplify it. That'll still be 10 factorial on top. And then we have 10 minus 3, which is going to be 7 factorial, and still bring down 3 factorial. So let's break 10 down. And remember, we're going to go to just break it down to the largest number that's in the denominator. Because remember, if we're looking at this like a bag of Skittles or a can of corn, remember that inside of that factorial are still all the other numbers counting down to 1. So we'll go 10 times 9 times 8 times 7 factorial over 7 factorial, where those 7 are 1 and 1, because both of them consist of 7 times 6 times 5 times 4 times 3 times 2 times 1. So instead of going all the way down, we could just cancel those or reduce those to 1 and 1. So now let's break down our 3 factorial. The 3 times 2 times 1. We know that 3 can go into 3 once. 3 can go into 9 3 times. 2 can go into 2 once. And I'm going to say 2 can go into 8 4 times. So now, I'm sorry, that's supposed to be a 1. So now in our denominator, we have 1, 1, 1, 1. So everything in the denominator is 1. And now on top, we have 3 times 4 is 12 times 10. So our combination is going to be a total of 120. So let's go to the PowerPoint, and they should give us some of the same information, but just not as much. We have 10C3, which is 10 factorial over 10 minus 3 factorial, 3 factorial. 10 factorial over 7 factorial, 3 factorial. Once we simplify, they did the same thing we did, and they went to do the breakdown to 7 factorial, where the 7s cancel out to 1 and 1. 3 goes into 9 3 times, 3 goes into 3 once, 2 goes into 2 2 times, 2 goes into 8 4 times, which is a summary of 120. So it's 120 different ways that he can visit 3 different cities out of 10 over a long weekend. Okay, our next example. At one school, the student government consists of 7 women and 5 men. How many different committees can be chosen with 3 women and 2 men? Okay, so for this one, I am going to pull out pencil and paper because I'm going to need more space than what that board can give me. Okay. So I hope that you can still see this. I will turn it this way. All right, so here, remember, they said at one school, the student government consists of 7 women and 5 men. How many different committees can be chosen with 3 women and 2 men? So the first thing we need to make sure we understand is what we have to start with. We have 7 women. We're just writing our information down. 5 men. How many positions do we have available? They want 3 women and 2 men. So 5 positions. That's just general information. All right, so we're going to have to do 2 setups of combination rule, where the first one is going to be the women. So we're going to put NCR, which is nothing but the actual equation of combination rule. So we have NCR equals N factorial over N minus R factorial times R factorial. Let's substitute our numbers in. So for women, we have a total of 7. And we have how many positions for the women? 3. So now we use substitution, and we get 7 factorial over 7 minus 3 factorial, 3 factorial. So now we come on down and simplify, which is 7 factorial over 7 minus 3, which is 4 factorial, 3 factorial. So now we basically do our countdown to the largest number in the denominator. So we have 7 times 6 times 5 times 4 factorial. Where we have 4 factorials canceled to be 1 and 1. And let's break down the 3 times 2 times 1. In this case, we know that 3 can go into 3 once and 3 can go into 6 twice. So we don't have all 1s in the denominator, We have a 2 in the denominator here. And we have 7 times 2 times 5. 2 times 5 is 10 times 7, which is 70. And 70 divided by 2 is 35. So there are 35 different ways to get 3 women out of 7. So now let's go to men, which we have NCR is equal to N factorial over N minus R factorial R factorial. So we're going to plug in for men. We have 5 men, and they told us we have 2 positions for men. So we have 5 total men and 2 positions on the government for them. So we have 5C2 is equal to, let's go ahead and substitute, 5 factorial over 5 minus 2 factorial 2 factorial. That's substituting those numbers into the equation. Now we have simplifying, where we have 5 factorial over 5 minus 2, which is 3 factorial. Then bring over the 2 factorial. From this point, we're going to do our countdown to the highest number in the denominator, which is 3. So we have 5 times 4 times 3 factorial. And let's bring over the 3 factorial first, because they cancel out to 1 and 1. And then with our 2 factorial, it breaks down to 2 times 1. 2 can go into 2 once. 2 can go into 4 twice. So we have 2 times 5, which is 10. So there are 10 different ways that we can get 2 men out of 5 men. So in order to figure this problem out, we have 35 women times 10 men. So in totality, we have 350 ways that we can make, 350 ways that we can create this committee out of 7 women and 5 men. So here in their solution, they tell you we can do 7C3, which is 35 ways, and 5C2 for 10 ways. But remember here, we just worked the entire problem out where you can see how to plug it in, or plug them both in, and actually plug them in, simplify them, break them down, then find our numbers and multiply. And they just give us the simple version of 35 times 10 is 350. All right, our example says to raise money for a charity event, a sorority plans to sell a calendar featuring tasteful pictures of some of the more attractive professors on campus. They will need to choose 6 models from a pool of finalists that includes 9 women and 6 men. How many possible choices are there if they want to feature at least 4 women? So for this one as well, we'll be using paper because it is a rather lengthy problem. We also need to identify that we have a total of 9 women. A total of 6 men. And they told us that for the calendar, they want to have at least 4 women. At least 4 women for their calendar. So now let's go back to this one spot for a second to make sure that everybody understands what we're doing. To raise money for a charity event, a sorority plans to sell a calendar featuring tasteful pictures of some of the more attractive professionals on campus. They will need to choose 6 models from a pool of finalists that include 9 women and 6 men. How many possible choices are there if they want to feature at least 4 women? So we have 6 total positions. And they said at least 4 women. So that means for women, if they want at least 4, that means we have to find a combination for 4 women, 5 women, and 6 women. So we have we have 9C4 because they said at least 4 women. We're going to have 9C5 because at least means the minimum. So we can also have 5 women. And we're going to have 9C6 because remember, that means that in totality, we can have up to 6, but no less than 4. So that's for women. Now, let's come over here because if they have 4 women, 5 women, or 6 women, and positions are left, that means we're going to have, if there are 4 women, there are only going to be 2 men. So we're going to have 6C2. 6C1 and 6C0. So that means 4 plus 2 is 6. 5 plus 1 is 6. And 6 plus 0 is 6. So we still have 6 spots with those vast amount of women and men. All right, so now we're going to work 9C4, where we're going to 9 factorial over 9 minus 4 factorial 4 factorial. That's substituting. Sorry, I'm trying to catch the focus. Sorry about that. So now we're going to simplify. 9 factorial. 9 minus 4 is 5 factorial. Bring over the 4 factorial. And now we're going to do our breakdown to 5 factorial since that's the largest number in the denominator. So we have 9 times 8 times 7 times 6 times 5 factorial. We're going to put it over 5 factorial with those canceled out at 1 and 1. We're going to do our 4 breakdown. 4 times 3 times 2 times 1. Like I said, I apologize for the focus. I'm doing the best I can, and this is the reason why it's taking so long to get the videos. Alright, so 4 can go into 4 once and go into 8 twice. 3 can go into 3 once. 3 can go into 9 3 times. 2 can go into 2 once, and 2 can go into 6 3 times. So everything here in the denominator is 1, and we're left with 3 times 2 times 7 times 3, and we get 126. So there are 126 ways to get 4 women out of 9. So now we're going to do the men that go with that particular one. where we have 6 factorial over 6 minus 2 factorial, 2 factorial. That's our substitution. Our simplification is 6 minus 2, which is 4 factorial, and 2 factorial, bring down. So since 4 is our largest number in the denominator, we're breaking down to 6 times 5 times 4 factorial over 4 factorial, which those cross out to 1 and 1. Breaking down 2 times 1. 2 can go into 2 once, and 2 can go into 6 3 times. So we have 3 times 5, which is 15. So what we're going to do for the 9C4 women, which is 126, and the 6C2 women, men, I'm going to go to the top right here and do 126 times 15. And I get 1,890. We're going to leave that there for a second and come back down here, and let's go to 9C5. Let's substitute. We have 9 factorial over 9 minus 5 factorial, 5 factorial. That's just substitution. Now we're going to simplify. We have 9 factorial over 9 minus 5, which is 4 factorial, 5 factorial. Now, if you look above, those look remotely close. The only difference is the 5 and the 4 are switched. So we can just go ahead and still go to our highest denominator number, which is 5 factorial. So we have 9 times 8 times 7 times 6 times 5 factorial. Put it over the 5 factorial where those cancel at 1 and 1. Then 4 times 3 times 2 times 1 again. 4 can go into 4 once. 4 can go into 8 twice. 3 can go into 3 once. 3 can go into 9 3 times. 2 can go into 2 once. And 2 can go into 6 3 times. So for this same one, or the second one, we also have 126. So if we come over to 6C1 and substitute, we have 6 factorial over 6 minus 1 factorial, 1 factorial. We're going to simplify. We have 6 factorial. 6 minus 1 is 5 factorial, and 1 factorial. So when we break it down, it's simply 6 times 5 factorial, where our 5 factorial comes down because it's the highest. So we have 1 and 1. And 1 factorial breaks down to 1. So for men, we just have 6 ways that we can get one person out of 6. So we're going to go back to the top. And we're going to take that 126 from that second one times 6. And we get 756. Different ways that we can get 5 women and 1 man. So the last one we have here is 9C6. Go down a little bit because I know I wrote kind of close. I'm sorry. We have 9 factorial over 9 minus 6 factorial, 6 factorial. That's substitution. Now let's simplify. We have 9 factorial, and 9 minus 6 makes that 3 factorial, 6 factorial. We're going to do our breakdown to the largest number in the denominator. So that gives us 9 times 8 times 7 times 6 factorial over 6 factorial, where it's 1 and 1. 3 times 2 times 1 is breaking the 3 down. 3 can go into 3 once. 3 can go into 9 3 times. 2 can go into 2 once. And go into 8 4 times. So we have 3 times 4 times 7, and that gives us 84. So out of 9 women that will fill 6 positions, there are 84 ways. Now let's come over here to 6C0 for men. We're going to plug in 6 factorial over 6 minus 0 factorial, 0 factorial. We're going to simplify where we have 6 factorial, and we know that 6 minus 0 is 6 factorial, and bring over the 0 factorial. Now, first things first, 0 factorial, as we know, is always the number 1. And then because we have 6 factorial and 6 factorial, that is 1 and 1. So our answer is 1. So we're going to go back to the top and do 84 times 1. Times 1 is 84. So now with these 3 numbers that we have, we're going to add them in order to get how many different ways that we can get at least 4 women in this calendar. We have 1,890 plus 756 plus 84. And we get 2,730 different ways. So when you come here to the actual PowerPoint, they're going to give you the 2 numbers that we just identified, which was at least 4 women, which was 9C4, which made it 2 men, which is 6C2. They already gave you the simplified combination rule with those numbers in it. And they got 126 times 15, which is 1890. For the second one with 5 women and 1 man, they gave you the simplified combination rule, which we just worked out, and got 126 times 6 with 756. And for the third one with 6 women and no men, we have the simplified version of the combination rule, which gave us 84 times 1, which was 84. And our total, 2,730. So as we see, this completes our chapter 11.2 or chapter 11, section 2. This is just an overview of the work we just did. If you get a chance to look back at it, please do. And I have 11.3 through 11.9 coming today, so watch out for it. Y'all have a good day. Stay safe.